Hello student. In our previous lecture, we have discussed about the extraction process of metal ion by chelate formation. The extraction efficiency depends on the concentration of chelating reagent and at acidic pH the extraction will be more for the metal ion. Then we have also see the separation efficiency of two different metal ion by chelate formation, and this separation efficiency is represented as separation factor for metal ion separation. Now in this lecture we will see the analytical separation. The solvent extraction has one of the most important application in the separation of metal cations. In this technique, the metal ion through the appropriate chemistry, that means to form the metal association complex, chelate formation, and then distribute between the aqueous and organic phase. This technique is extremely useful for very rapid and clean separation of both organic and inorganic substances or analyte. The solvent extraction of metal ion into the organic solvent by the formation of metal chelate using a suitable chelating reagent at definite condition. Extraction of heavy metal from the polluted water can also be achieved by this solvent extraction process. Determination of lead from the blood sample can be extracted by using a chelating reagent dithiazone at pH range 8 to 10. The dithiazone form a chelate with the lead, and that can be extracted in organic layer of solvent methyl chloride. The excess of interfering ions that can be removed or blocked by a masking agent at definite pH. This separation can be achieved by the simple technique solvent extraction technique. So next topic will be multiple batch extraction. That means it is also solvent extraction process. That means the extraction process is carried by multiple batches. So let us see what is multiple batch extraction. The solvent extraction is a efficient technique for the separation, isolation of organic and inorganic compounds. But the mixture with a small polarity difference between the molecules, then total separation is not achieved by the single extraction. For such mixture, several time extraction is carried out to achieve a complete extraction. Such process of extraction is called as multiple batch extraction. The efficiency of extraction is measured in terms of solute remain unextracted. The amount of solute remain unextracted represented by a symbol Wn, and in multiple n operations is given by the equation, that is Wn, that means solute remain unextracted, is equal to Wa that is initial concentration of solute, bracket Va, that is volume of aqueous layer, divided by D into VO. D means distribution ratio of solute, VO means volume of organic layer, plus Va, that means again volume of aqueous layer, bracket raised to n, that means n operation, that's why multiple batch extraction we can say, where this constant or symbols is Wn is a solute remain unextracted in aqueous phase, Wa is the initial quantity of solute in aqueous phase, this is small n is the number of operation, that means raised to this equation, D is the distribution ratio for the solute, Va is the volume of aqueous phase, and Vo is the volume of organic phase. So this equation can be derived by the several steps, that is derivation of solute remain unextracted Wn. We know the percent extraction in a single operation can be given by the equation, that is percent E is equal to 100 into D divided by D plus volume ratio Va upon Vo, that is aqueous to the organic. Therefore, the fraction of solute extracted can be calculated by dividing 100, because here percent we want to the fraction, so we divide by the 100 to the above equation, we get fraction of solute extracted F is equal to D upon D plus Va upon Vo. This 100 will be cancelled. The fraction of solute remain unextracted will be, so this is fraction of solute extracted, so fraction of solute remain unextracted will be equal to the 1 minus F, that means total 1, and that much fraction will be extracted. So what is unextracted? 1 minus F. To substitute the value of fraction extracted, 1 minus D upon D plus Va upon Vo. To make the base equal, so this whole thing will be multiplied by this side, that is by 1, that means D plus Va upon Vo minus D, this D minus D, then base will be the same, that is D plus Va upon Vo. Again we rewrite the equation, D plus Va minus D, and this Vo will be divided to this side, then D plus Va upon Vo, and this Vo here into Vo. So this D plus and D minus will be cancelled. This Vo and this Vo will also cancelled. So we get the final equation, that is the fraction of solute remain unextracted is equal to Va divided by D into Vo plus Va. Then let Wa is the initial concentration of solute in moles present in aqueous phase. So W1 is a fraction of solute remain unextracted in aqueous phase after one extraction or first extraction. Then we can write the equation, W1 is equal to Wa into Va into d Vo plus Va raised to 1, that means fraction of solute remain unextracted, and this is initial concentration of solute. So fraction of sample unextracted in first extraction will be the Wa into Va upon dVo plus Va raised to 1, that much fraction is unextracted. multiply by the total concentration. So we get fraction of solute remain unextracted. For second extraction, W2 is the fraction of solute remain unextracted in aqueous phase after second extraction. Then W2 is equal to WA in initial concentration bracket VA upon D into VO plus VA raised to second, that means second extraction. Similarly, for number of extraction, the amount of solute remain unextracted in nth operation, then solute remain unextracted will be Wn. Then Wn is equal to Wa initial concentration into bracket Va upon D into Vo plus Va raised to n. This is your final equation. That means fraction of solute remain unextracted. The fraction of solute extracted can be determined. The fraction of solute extracted is equal to initial fraction minus unextracted sample. That means how much sample will be solute will be extracted, that can be determined. On this equation the numerical may ask to you. So here we stop the lecture. In next lecture we will see the counter current distribution experiment. That means multiple batch extraction is carried out by a counter current distribution by using a Craig's apparatus. Thank you.